So in this video, we are going to talk about support vector regression. So basically, our problem statement is same as we did in polynomial regression. So we are given the task to find out the salary of a new employee who was previously a region manager at the previous company. He is demanding a salary of around 180,000, and we as machine learning engineers were given the task to see if 180K salary is justifiable for his position or not. Okay, so we will start by importing our libraries. So we are using basically four libraries, which are NumPy, Pandas, Matplotlib, and the scikit-learn to import our support vector regression model. NumPy is basically used to deal with arrays, as we are going to use a 2D array, and Matplotlib is used to visualize the graphs and better understand how our regression model works. And Pandas is basically used to access the data set as a data frame, so that that data frame can be fitted into our machine learning model and it can make predictions. So now next thing is to import the data set. So basically we are going to use the level column as our independent variable and the salary column as our dependent variable, because the level column determines the salary. So basically, if you are level 1, then your salary will be around 45,000. If you are level 10, your salary will be $1 million. Or for that matter of fact, it can be any other currency. That currency doesn't matter in our case. We are just given numbers. So now let's import the things into X and Y, and let's print X and Y as well. So as you can see, we get the levels as a 2D array and 1, 2, 3, 4, and in Y we get a 1D array corresponding to the different salaries according to the levels. Okay, so now what we need to do is in support vector regression, and you can also apply these things into the previous models as well. That is called feature scaling. So basically, we have to apply feature scaling because the values of x and y, they are very different. For example, x varies only from 1 to 10, but y varies from 45,000 to 1 million. So as you can see, there is a lot of difference. First of all, when you compare the first one, that X, the level is 1 and the salary is around 45,000. So it is 45,000 times more than the level. And then when you go at level 10, the salary is $1 million. That is 100,000 times more than the level. So for our machine learning model to better understand what are the independent variables and dependent variables, and then to make connections between them, we need to feature scale these things. So we what we are going to do is we are going to scale these things from -3 to 3. So basically we are using standard scaler, and when you use the standard scaler, most of your values get scaled down to a range of -3 to +3. So which helps our machine learning model make better connections, and also the processing time of our model becomes lesser. But to apply standard scalar, we need our data set to be a 2D array. So as you can see, our x is a 2D array because it is opened using two square brackets and it ends using two square brackets. But our y parameter is not a 2D array, it is a 1D array. So what we need to do is we need to convert this thing into a 2D array. So you can simply change the dimension of any array using y dot reshape, and we are going to use the length of y. And what we are also going to do is add one parameter so that it becomes vertical. So when I run this code, as you can see, now it corresponds to a 2D array and it is also vertical. The vertical part is basically because our x here is vertical. If our x here was horizontal, then we would have taken y also here as horizontal. So for example, if you change it to 0, we will get a horizontal 2D array. Okay, so it gives an error because we cannot change the shape of uh, into a horizontal array, it is giving some error. So basically, let's just do it in this way, and let's just check what will happen if I put 2 over here. Okay, so we cannot do it in this case. So if it is a 2D array, you have to do it in a vertical representation. So the next thing is feature scaling. We are going to apply the standard scalar function on our variables, the independent variable and the dependent variable, using the pre-processing module of the scikit-learn library. Okay, so we are going to make two functions, two standard scaling functions. One will be used to standardize the values of x, and the other function will be used to standardize the values of y. We we are not using. We can also use only one function, but as you can see, the values of x and y are very different. So that means when you change the values of x, for example, when you fit x into the standard scalar and transform these values, that standard scalar has some weights or parameters attached to it. So when you fit these 1 to 10 numbers, it will have some different parameters, and when you fit these 45,000 to 1 million numbers, it will have some different parameter. So that is why we need to use two different standard scalars. And what will happen is when you fit and transform x part, it will start from zero, and it will, on the basis of x, determine how much it should standardize. And for the same as y, uh, the y will be scaled according to the values from 45,000 to 1 million. It will start from zero. For example, for example, let me tell you, let's say if we only do the scaling of x. So let me scale x first. Yeah, so let's print. So as you can see, the value varies from minus 1.566 to plus 1.566. And now let me add something. Let me add the part that I deleted. Okay, and now let's transform y. So as you can see over here, ry also changes. Goes from minus 0.72 to 2.642. And if we use sc underscore x, because this is also a standardizer, we will get different values over here. Let's check. Okay. So as you can see, we get somewhat different value over here. Uh, but mostly I believe these are same. The reason for that is we are using only 1 to 10 numbers. Our data set is very small, and it made some correlation with ry. So it almost gave out the exact result. But as a machine learning engineer, it's a good practice to use different standard scalars for different columns, and especially if there is a very big gap between the values of different columns. So now let's run this part again. Okay, so now we need to train the support vector regression model on the whole data set. So here we are using the RBF kernel. You can also use the linear kernel or some other kernel. What you can do is you can go to the API of scikit-learn, and from there you can see what different kernels you can use. So this is the API of SVC, and we are using the RBF kernel, which is the default kernel, and all these things you see here, the degree is default, the gamma is scale, so all these values are default. So if we look at the kernel column over here, we have we can use linear kernel, we can use polynomial kernel, we can use RBF kernel, we can use sigmoid kernel, or we can use pre-computed kernel. So what we'll do is we'll first use the RBF kernel, and then we are also going to use the polynomial kernel to see how results vary. Okay, so let's start with the RBF kernel. So we get an output of 170,000 and 370, which is close to what that person was asking. He was asking a salary of around 180,000, and our model predicts that his salary should be around 170,000. So we can inform the HR team that his salary should be around 170,000. And we can see from this that we have also taken into consideration that 0.5 factor that increased his salary from 150,000 to 170,000 and 370. So now let's visualize these SBR results. Yeah, so as you can see, our model does almost okay. It doesn't detects any value correctly, but it's in the vicinity of the correct values. But it doesn't really guesses the value of our CEO correctly. So it works well for the lower positions, but when you reach a higher position, it doesn't work. So this is the thing this is the point that we can take from this model, that it doesn't really work on classifying the salary of a CEO. For example, if I write 10 over here, it gives a salary of only around 557,000. But we know, as a matter of fact, that the salary of our CEO is $1 million. So it's reducing his salary by 50%. So which is very wrong. Also, let me tell you how we are predicting this value. So basically, what we are doing is we are standardizing the input which we are giving. For example, if we give an input of 6.5, the SC underscore X standard scalar is going to transform this 6.5 to a value between minus 3 to plus 3, as we did for this part over here. And then we are going to reshape it into a vertical format and into a 2D array. It is already in a 2D array, but we are still going to use this reshape function so that it doesn't give any error. So I tried removing this part, that reshape part, and it gave some error. So I'm sticking with minus 1 comma 1 over here, so it doesn't return any error. Also, then we are going to do is we are going to predict that standardized values by putting it into a regressor model. And if we, for example, if we don't use this part, let's just let's just do this and remove these brackets from here. Okay, so this gives the value of you can see minus 0.276, but our value of salary should never be negative, and we can also see that it's giving a value close to zero, so which means that this is not the correct answer. So basically, what it's giving is it's the standardized value of the output. For example, let me show you over here. We were getting the Y column and we were getting the standardized values. Like for example, minus 0.72004 corresponds to 45,000. Then similarly, 1.56666989 corresponds to 1 million. So basically, we are getting this value, but we need to get this value, the correct value. So what we need to do is we need to inverse transform the values, because we are getting the transformed output. So what we need to do is we need to get the inverse transform of the answer that we are getting. So it's nothing that we it's nothing but we are going to use the SC underscore Y, and from that we are going to use the inverse transform regressor. Okay, so basically something is missing over here. Let me add it. Yeah. Okay. So basically now it works, and we get the new salary of around 170,000 and 370. This is how this works. Also, we can also try different kernels from here. Let's try with poly. So what we have to do is just change this RBF to POLY. Okay, and let's run these cells from here. So our model was made using the kernel as poly. And see, our this polynomial kernel predicted his salary to be around 200,000, which is a lot, and which is more than what the employer was asking. And let's see how our results did by visualizing them. Okay, So as you can see, that our model did not do very well, especially for the starting values. It predicted the values from 7, 8, 9 onwards pretty accurately, but in the starting part, it did not do very well. Let's also try the sigmoid kernel, and let's see what output we get from that. Okay, so our sigmoid gave an answer of 350,000, which is approximately two times what the salary of that individual was asking. And as you can see from this, that our support vector regression model didn't do very well. So similarly, you can try all these things. You can try changing the degree. You can try changing gamma. You can try shrinking. So these things you can try on your own and see which model you think would work better in this case. As the data set is very small, we cannot use the accuracy parameter just yet. So we have to visualize and see for ourselves what regression model suits best our data set. Okay. So basically, the RBF one works best in our case. I already used different parameters, and therefore I reached the conclusion of using this RBF kernel instead of any other kernel. But you feel free to, change these values. You can see our model does very well compared to the other kernels. Okay, so basically this is it from support vector regression, and I'll see you guys in decision tree regression. Thank you.